Hi, everyone. Thanks for your interest in my lab. My name is Rob MacCurdy, and I'm an assistant professor in the Robotics and System Design Research Focus Area of the CU Boulder Mechanical Engineering Department. I lead the Matter Assembly Computation Lab and have been at CU for 2.5 years. Our research in the Mac Lab is motivated by the observation that designing robots and electromechanical systems is difficult, time-consuming, and requires a great deal of experience. Practitioners need to be skilled in mechanical, electrical, and computer engineering. Instead, what if making a robot could be as easy as specifying the behaviors or capabilities you want, asking software tools to design the robot, and then printing the robot? This is the overall inspiration for what we're trying to do in the Mac Lab. In support of this general goal, we work in several sub-areas: design automation for multi-material fabrication, fabrication automation, which involves making new 3D printers and control software, multi-material simulation, and 3D printable material development and testing. The design automation and multi-material simulation research areas are all about automating the process of synthesizing a multi-material design that meets certain performance criteria. We are developing algorithms based on multi-objective optimization that specify the precise locations of materials with different properties within an object, and then efficiently simulate the mechanical behavior of that object. The fabrication automation research area is focused on building functional objects from multiple materials automatically. The vision is that robots and other electromechanical systems are ready to use when you remove them from the printer. To do this, we are developing algorithms to verify that a particular multi-material design will actually be printable, even if it includes some materials that are as stiff as epoxy and others that flow like water. We develop our own multi-material 3D printers, and we also use 2 commercial inkjet printers capable of depositing up to 8 different material types in a 3D object. Finally, we are developing new materials for 3D printing and characterizing them. Some of these materials are formulations that we mix up in the lab and feed into the printer, while others are actually produced during the printing process by precisely controlling the amount of each different material channel that is deposited. Part of this research involves characterizing the materials, some of which are treated as bulk continuous materials with properties that are controlled by the print process, while others are metamaterials that can be controlled on the fly by external stimuli. These are interdisciplinary and interrelated research areas, so my students work in small teams on these tasks, with each one taking the lead on a specific project. If you're interested in learning more about these topics, my lab website has more details, and I also teach 2 related classes that you can find on our department website. Thanks.